topic is model analysis from orthodontics. Now this model analysis, it is one of the essential diagnostic aid. The important purpose of the orthodontic study model is to get this model analysis. So this model analysis, it is done with the help of those study models, and they provide a three-dimensional view of the maxillary and the mandibular dental arches, which we cannot view directly in the oral cavity, and hence we are doing this model analysis. And this model analysis is important because this is a compulsory thing that you do in your practical exams, and any of the analysis, it can be even asked as a short answer question in your theory exams too. So we should know exactly how this model analysis is done and everything about all the analysis. So I'm going to actually show you practically how you're going to do all the analysis. Now the classification for model analysis is, it is classified depending upon the permanent dentition and mixed dentition. So these are all the analysis which you do in the permanent dentition. So this is the arch perimeter, Nance and Carey, Ashley-Zoe, Pons, Linderhart, Korkhoz and Boltons. So these are the analysis that you do in permanent dentition. Now in mixed dentition are these four: Moyers, then Tanaka and Johnston, Nance and Hukaba. So these are the ones that are done in mixed dentition. So I'm going to explain this analysis by showing it how you are doing them. Model analysis, it helps to study this maxillary and mandibular arches in three planes, that is sagittal, vertical and transverse. So we are studying this study models in all these three planes.
So how we used to do in our college, I'm going to show it like in a form of video which you'll find on the Instagram page, and this is how we used to do it.
Starting off with the first analysis, that is the arch perimeter analysis. And this arch perimeter analysis, it helps to determine the difference between the space which is available and the space which is required. So it is nothing but the difference between space available and the space which is required. So how much is the space available in your cast and how much is the space which is required for the treatment to be done. So this is the things that helps in this arch perimeter determination. Then over here what we are doing is basically we are doing this calculation. So in arch perimeter we do this calculation of the space required and calculation of the space available. So space available calculation is done with the help of a brass wire. So this arch perimeter, it is done in maxillary cast, and if it is done in mandibular cast, then it is known as Nance and Carey's. So basically the procedure of both, it remains the same, but the name for mandibular is Nance and Carey's and arch perimeter is for the maxillary. So the procedure is going to be same for both the analysis. So first what we do is, first we are going to see the calculation of the space required. Now how much is the space required? So in this thing, what we are going to see is the tooth material or the linear dimension. What we used to do is, we used to follow this formula, and this formula is nothing but, this linear dimension is nothing but LA plus 2x. So this is nothing but, LA is nothing but the sum of incisor, and this x is, you're going to see the mesiodistal width of canine, premolars, so the first premolar and second premolar. So this is your LD which is going to come. So basically this total tooth material, or basically the calculation of the space which is required is nothing but, you're going to calculate the mesiodistal width. So basically you're just going to calculate or measure the mesiodistal width of all the teeth which are mesial to the molar. So you're going to calculate the mesiodistal width of all these 10 teeth. So basically you're going to start with the calculations. So first, so this is 10 mm, this is 10 mm. So you just have to calculate it. I'm just saying it. You have to keep it on the scale and have to calculate it properly. Then this can be 9 mm. Then you have to calculate it 6 mm. Then like this you just have to calculate from premolar of one side to the premolar of other side. So these are the 10 teeth that you're calculating, and this is nothing but the space which is required. So first we have seen the calculation of the space required, and next, so you have to write whatever the calculation has came. So for example, the calculation is 80. For example, if it is 80, so the space required is 80, and space required is nothing but LD or the tooth material in which you are just measuring the mesiodistal width of all these 10 teeth. Then next is the calculation of the space which is available. Now this we are doing with the help of a brass wire. Right now I don't have a brass wire, so this is just a normal stainless steel wire which I am using. But brass wire is quite like easy to mold. So you just have to do, what you are going to do in this space available is you are going to measure this arch perimeter using this brass wire. So what you are going to do is from the mesio-buccal line angle of the maxillary right first molar, you are going to pass this wire. So basically from here on the buccal side, that is mesial to your first molar, you're just going to pass your brass wire like this till the other side of your mesial to the first molar. So like this you're going to pass your brass wire. And if now, for example, now if the teeth, so if your incisors, they are proclined, so in this the brass wire, it will go from the cingulum area because these teeth are proclined. So it will go like this from the cingulum area. But if the incisors, they are retroclined, so it will go from the buccal surface. So like this it will go. And if it is normal, like if it is positioned normal, then it will go from the incisal edge. So it should follow this. So your brass wire is going to follow like this. From the cusps of your premolars, then the canine, then your incisal edge till like this on the buccal cusp. So after that what you're going to do is, now you have measured it, so it was over here. So you're just going to straighten that brass wire. And then you're going to calculate it on the scale. Just make it a point that your wire is completely straight. And then you can calculate it. And the calculation over here is coming out as 82. So then you have to write whatever the brass wire calculation is, that is 82. So brass wire calculation is nothing but the calculation of the space available. So now basically it's like the space which is available in the arch is 82 and the space which we require is 80. So over here now the space which is available is more than the space which we require. So the inference it will be, so now then you have to just see the difference. So difference is nothing but you're just going to minus it. 80 minus is minus 2. So if the inference, so in inference, if your difference is coming negative or it is between 0.0 to 2.5. Now if this difference is coming negative or if it is between 0 to 2.5, it means it is a non-extraction case. So you don't have to extract the teeth because now the space which is available is more and the space which we require for the correction is less. You need to actually extract any tooth. But now as we have seen, the difference is minus. So if there is difference of 1, for example, if there was a difference of 1 mm, so what you can do in that case, you can just do the proximal stripping. So you just have to reduce the incisors. So you just have to reduce it from the either side, and that is nothing but the proximal stripping. But now if the difference is coming as 2.5 to 5, so if the difference would be 2.5 to 5, then you have to extract second premolar from this side. So you have to just extract the second premolars.
And if the difference is more than 5, then you have to extract first premolars. And this is the first analysis, that is arch perimeter and Nansen caries.
What is this Ashley's Ho analysis? So Ashley Ho analysis, it is basically, he considers, so this Ashley Ho, he considered the crowding of the teeth to be the result of the deficiency of the arch width rather than the arch length. So we are going to determine these three things. So first is determination of the total tooth material, then determination of the premolar diameter, and next is the determination of the premolar basal arch width. So how we are going to determine this, I'm going to tell about this now. So first is determining total tooth material. So total tooth material is nothing but you're just going to measure the mesiodistal width of all the teeth, like 6, 5, 4, 3, 2, 1 and 1, 2, 3, 4, 5, 6. So you're going to calculate the mesiodistal width of this 12 teeth, that is first molar, second premolar, first premolar canine, central incisor and lateral incisor. So this is the total tooth material. So you have calculated the total tooth material. Then the next thing is determination of the premolar diameter. So first you have calculated total tooth material. So if your total tooth material, it is 100, for example. So you have like calculated mesodistally, so mesodistal width. So you have calculated the mesodistal width like this, and you're just adding them up. So these are the mesodistal width of all the 12 teeth, which is mesial to your second molar. Then you have calculated it. Then next is the premolar diameter. Now in premolar diameter, so the premolar diameter, it refers to the distance or the arch width from the tip of the buccal cusp of your first premolar to the tip of the buccal cusp of the opposite premolar. So what you're going to do is, you're just going to keep your divider on the buccal cusp of your first premolar and on the buccal cusp of the opposite first premolar. So like this, you're going to keep your divider on the buccal cusp of each of the first premolar. Just remember, it is first premolar, and then you're going to calculate it on the scale. So this is coming out as 43. So now your premolar diameter, it is 43, and next is the premolar basal arch width. So now what you're going to do is, you're going to measure from canine fossa of one side to the other side, and this gives the width at the basal bone. So this is nothing but it gives us the width of the dental arch at the apical base. But now you cannot see. So what is this canine fossa? So canine fossa is basically, it is like a depression which is made on the maxillary bone, and it is caused by this canines. So now you cannot see this on the cast. So what you can do is, the canine, if it is not clearly distinguishable, then you can measure it from a point that is marked 8 mm below the crest of the interdental papilla, which is distal to the canine. So interdental papillum, which is distal to canine. So this is your interdental papilla, distal to canine. So you're going to measure, so you're going to make a point which is 8 mm below the interdental papilla. So you're just going to measure it on this scale. First you're going to see 8 mm. Then you're going to keep it distal to the canine in the interdental, so below the interdental papilla, distal to canine, and then you're measuring it, and you're just making a point on that, on the either sides. So this is the point and this is the point. Then what you're going to do is, you're just going to measure it with the help of this divider. So this is how you're going to do it, and then you're going to measure it on the scale. So this comes out to us 41. So this is your premolar basal arch width. Now there are two inferences that you can determine from this Ashley's Ho analysis. So the first inference is, when you're comparing this premolar basal arch width with the premolar diameter. So you're comparing basically premolar basal arch width with premolar diameter. So first inference is, in this, these two are compared. Now if this premolar basal arch width, it is greater than this, then it says that there is an indication for the arch expansion is possible. So basically now your bone is larger and you can do the expansion of the cast. So you can do the expansion of the maxillary arch. And if your premolar diameter is larger, so basically it's like, if your premolar basal arch width, it is less than the premolar diameter, then their arch expansion is not possible, because now your premolar basal arch width is small and the diameter between the premolars is more. So in that case you cannot do the arch expansion. So in this case now you cannot do the arch expansion because your premolar diameter is more than the premolar basal arch width. So there is, like, you cannot do the expansion of the arches. What you can do is this formula. So this is the formula in which you are calculating the premolar basal arch width percentage, and it is calculated by premolar basal arch width upon total tooth material into 100. So now we have seen our total tooth material, it was 100. So total tooth material it was 100, and your premolar basal arch width, it was 41. So it is 41 into 100. So it get cancelled. So this is your premolar basal arch width percentage. So this is the premolar basal arch width percentage. Now the inference is, if it is 37 to 44%, if it is between 37 to 44%, then it is a borderline case. If it is less than 37%, so there is extraction which is required, and if it is more than 44%, then it is a non-extraction case. So basically if it is more, so there is no need of extracting the tooth. If it is less than 37%, then you have to do the extraction, and this is the borderline case. Next one is now the Boltons analysis. So this Boltons analysis, it was given by Boltons in 1909, and it is the method of determining the ideal dental arch width in the premolar and the first molar area, which is based on the sum total of the upper maxillary incisors. So it helps in determining the dental arch. It is narrow or it is normal. It determines whether there is need for lateral arch expansion, and it determines whether the expansion is possible or not. So these are the three things that you can see with the help of this Boltons analysis. So the way you are doing is, first you are going to see, so there are three things in which you are going to do is sum of incisor, then you are going to see the measured premolar value, then measured molar value, and then you are going to see the calculated premolar value and calculated molar value. So this calculated premolar and molar value is this formula. So first we are going to see the sum of incisors. Sum of incisors is nothing but you're going to just measure the mesodistal width of all the incisors of the maxillary arch, and suppose this is 32. So your sum of incisor is coming as 32 into 100 upon 64, and this is 32. So this is 80 is for premolar, and 64, when the denominator is 64, it is for molar, and when it is 80, it is for premolar. So like this you are going to calculate it. So you have to write it whatever the value is for premolar and for molar. Now this actual, so actual is nothing but this measured premolar value and measured molar value. Measured premolar value, so what you're going to do is you're going to keep divider on the distal pit of the first premolar to the distal pit of the opposite first premolar. So this is your first premolars, so you're going to keep it on the distal pit of this first premolars, on the either side, on the first premolars, and then you're going to calculate it on the scale. You're just going to measure it, and you're going to write the calculation as, so whatever the actual it was, and you have to, like for example, you got this calculation as 40, and now this calculation is 38. Now the actual is 38 and your calculated was 40. And in molar, what you have to do is you are going to keep your divider on the mesial pit of the first molar. In molar region, you are going to keep it on the mesial pit, and in the premolar, you are going to keep it on the distal pit. So this is how it works. Then you're going to just write it, and then you're going to see the difference between it. So over here the difference is in minus. So over here now, as you have seen, the difference is in minus. So this it states that now if the calculated value is more than the measured value, then it indicates there is need for expansion. So now your calculated value, so its calculated value is more than the measured or the actual value, so you have to do the expansion. And if your calculated value is less, for example, if your calculated value was 36, now the difference was 2, so now in this case there is no need for expansion. So the difference, if it is coming in negative, there is need for expansion. If it is coming in positive, there is no need of expansion. So this is how the Boltons analysis, and there are these two variations. So first one is the Linderhardt analysis. So it is basically same as that of your Boltons analysis, just the formula which we were using in the Boltons analysis is changed in this. So it is nothing but SI upon 100 upon SI into 100 upon 85 for the premolar, and it is for molar as sum of incisor into 100 upon 65. So we have seen in the Boltons analysis it was 80 for premolar and it was 64 for molar. So just this value is changed in this Linderhardt, rest is the same. And the next, Korkos analysis. So basically it is also similar to the Boltons analysis. Now only difference is it makes the use of Linderhardt's formula. Now we are using Linderhardt's formula in this Korkos and not the pons 1. So it was sum of incisor into 100 upon 85 and sum of incisor into 100 upon 65. So this is the formula that you use for Korkhoz also. And there's one more variation, that is, now you are making a perpendicular diameter. So you have seen the premolar from your distal pits and the molar from the mesial pits. So this was your pons analysis. But now in this you are also seeing a perpendicular distance between the incisors, central incisors. So this is your Korkhoz analysis. This is the perpendicular distance which is between the midpoint of the central incisors and the midpoint of your interpremolar distance. So this is the additional thing that you are doing for Korkhoz analysis. And in Korkhoz analysis there are like particular measurement which was given by Korkhoz. One is the Boltons analysis. Now what is this Boltons analysis? So Boltons analysis, in that you are going to do the anterior ratio, going to calculate the anterior ratio and overall ratio. In anterior ratio, what you're going to do is you're going to calculate the mesiodistal width of all the anterior teeth upon all the maxillary anterior teeth into 100. So for example, now your mandibular 6 total tooth material is nothing but, so you're calculating 1, 2, 3 and 1, 2, 3 on the either side of the mandible. Upon it is maxillary, so it is 1, 2, 3, 1, 2, 3. You're going to measure it and then you're going to write the measurement as, so mandible for example is 64 and it is 80 into 100, and overall ratio is for 12 teeth. So you're going to calculate 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6 for mandible, and for maxilla it is same, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4 from first molar to the first molar into 100. So this is your overall ratio. And then next you're going to do the calculation of it. So now for example, if your overall ratio, now you have calculated this overall ratio. So now if your overall ratio, it is greater than 91.3. So this is a fixed value that you have to remember. So if this is more than 91.3, so the calculation is coming more than 91.3. For example, it is coming as 94. Then you have to like apply this formula, that is sum of mandible. So in this case, if the overall ratio is more than 91.3, so it means your mandible is in excess. So your mandible is in excess, and because of that the ratio is coming greater. So what you are doing is the sum of the mandibular 12 is coming out of the bracket minus sum of the maxillary. So whatever the sum of mandibular 12 was, you are going to write it over here, minus sum of maxillary 12 into 91.3 upon 100. So this is the formula for overall ratio if it is greater than 91.3. But now if it is less than 91.3, so in that case now your maxillary is in excess, and because of that it is coming less than 91.3. So in that case you are going to take this maxillary out of the bracket. Then this is sum of mandible. But now in this you have to remember, if it is less than your 100, it is coming in the, so it is coming in the numerator, and your 91.3 is going in denominator. So this is the difference in both of this formula. So if it is more than 91.3, so your 91.3 is coming in the numerator. So this is for the overall ratio, and same is for the anterior ratio. So for anterior ratio, the fixed value is 77.2. So if it is more, so if your anterior ratio is more, so if it was 74 for example, so now if it is more, then if it is greater than 77.2, then you have to sum of your mandibular 6 minus sum of maxillary 6 into 77.2 upon 100. So if this value, so if the anterior ratio was greater than this 77.2, then this is the formula. Now as we have seen, it is less than 77.2. So if it is less than 77.2, then obviously you're not doing this formula, so you are applying the other formula, that is, in this now the maxilla is more, and because of that it is coming less. So you're going to like take the maxillary part out of the bracket. So this is the sum of maxillary 6 minus sum of the mandibular 6, and as I said, if it is less, then if it is less, then that fixed value is coming in denominator. So that was the 77.2. So this is the formula for your Boltons ratio. Basically your Boltons ratio, it determines the disproportion between the size of the mandibular and the maxillary tooth. So it is nothing but the discrepancy in the maxillary and the mandibular tooth, that is your Boltons ratio. And these all are the analysis which you do for permanent dentition. And that was it of this video. I hope you found this video helpful. Thank you so much.